Assalamualaikum, my name is Nur Afafhanani binti Zakaria and I will explain question number 1. So before doing the soldering process, explain the things to pay attention to. So the things to pay attention to before doing the soldering process are, first, we need to identify the correct components and confirm that their values are correct. It is to prevent from soldering the wrong components to the PCB board. Next, we need to make sure to understand and know about the polarity before doing the soldering process. If a component has a polarity, then we must pay closer attention to the polarity. Next, make sure to be aware or create the component that has a polarity in the circuit. For example, the LEDs and the capacitors. It is to prevent the circuit from malfunctioning after it has been soldered. Lastly, be aware of the right location to place the components to be soldered, as well as their polarity. It is to ensure that there are no mistakes with the placement at the soldering location. The above steps are important in order to avoid any mistakes and any rework in the soldering process. And that's all from me. I will pass to the next member.
Assalamualaikum and hi. My name is Nur Aini Nadira binti Kamal Arifin. My matric card is CE19001. So for this lab 4, I will show and answer the question for question 2 and 3. So for question 2, state the equipment used to perform the soldering process. First is soldering iron. Second, soldering wire or copper. Solder sucker, tweezer set, solder stand, and then wire cutters and soldering sponge. So for question 3, describe the things to pay attention to when installing components on a PCB. First is understand mechanical constraints. The best PCB layout start on a foundation of great component placement, and there is no reason to rush through the process. Second, understand assembly constraints. Before you ever place a part down, you will want to understand a few pieces of information from manufacturer, including how is your board going to be assembled and tested? Will you need to add any clearances to your board for V-scoring? And how are your components going to be assembled by wave soldering, selective soldering, or hand soldering? And then how will your board manufactured will ultimately determine what kind of space you have to work with during your component placement process. For the example, if your board is going to be assembled along a conveyor belt, then we will want to keep parts away from the edge of your board to prevent any damage during assembly and processing. So third is keep similar components in the same direction. For groups of similar components, take the time to orient all of them in the same direction in evenly arranged rows or columns. Doing this will make it easy for your manufacturer to install, inspect, and test all of your placed parts. This ends up being critical if you are working with surface mount components or SMDs which use a wave soldering process. This is I got from some articles that I researched. So when you have to expose metal surfaces like a lid in a hole, as the wave solder passes over a solder joint will get formed, allowing an electrical connection to flow between your board and component. Fourth, group your path to minimize connection path. When you place your components, minimize any intersecting and crisscross of connection path. When you transform a schematic into a PCB layout in practice 8, you will notice that each of your parts has a very thin line that connects to another part. Please, number 5, place all your edge components first. First, place all of the components that can't be moved due to a mechanical enclosure like connectors, switches, jacks, USB ports, and anything else. The placement of these components is all set in stone and are typically out of our control if you are working with a mechanical designer. 6. Avoid overlapping any parts. Never ever cut corners if you are working with a small board size by overlapping parts, being either the pad or the part outline. Keep at least 40 mils of space between all of your parts. Parts means the components. Each footprint that you place on your PCB contains a set of copper pads that will have an electric connection. If you overlap two parts and the pads touch in even the slightest amount, then you will allow a stream of electricity to cross between components. 7. Keep your parts on one layer. If you are working with a simple 2-layers board, then we always recommend placing all of your parts on the top layer. Manufacturing a physical PCB is a time-consuming process and an expensive one if you end up placing components on the top and bottom layers of your board. Number 8, keep all pins and polarized components in the same direction. Every integrated circuit has an identifier that shows where pin 1 is, and you can take advantage of this by always aligning pin 1 on all of your ICs in the same direction. The same goes for polarized components. Make sure that the positive leads are all placed in the same direction. By placing all of your ICs in the same direction, then you will ensure that no mistakes are made when it is time to solder and inspect your board. And last but not least, design your PCB layout like your schematic. You will save a ton of time in the process and make your design easy to compare between schematic and PCB layout. This will also have the benefit of minimizing the length of traces since the parts you are placing are already logically grouped together based on your schematic. For example, if you have a big microcontroller to place, you will want to place the part first, then all of the supporting components like resistors and capacitors around it. This will make it easy to route your IC and all connected components with trace length that are as short as possible. So that's all from me. Thank you.
Next, I will explain question 4. Suppose you have installed the components on the PCB with reference to Lab 2 3D visualization. Take the top view and the bottom view to show the installation of the components of the circuit. So this is the top view and this is the bottom view of the circuit. I will show the 3D visualization in the Proteus software. So this is the PCB layout of the circuit. And this is the 3D visualization from the Proteus. This is the top view. And this is the bottom view of the PCB board. Here we can see that the components have been soldered to the PCB board. We can see that each component have been soldered to the PCB board. And that's all from me. Thank you.
Assalamualaikum, I'm Nurhani Shazwani binti Mokhtar, my matric number CE190207. I want to present on my part, which is question 5. Are there any other alternative soldering technique besides a manual soldering to assemble the component? Briefly explain. Other alternative soldering technique is selective soldering. Selective soldering is a type of way soldering mainly used for soldering printed circuit boards, partially or fully assembled using through-hole components. With a selective Nordson Select soldering machine, standard nitrogen inerts, and soldering port designed with titanium material for resist the corrosive effect of aggressively free soldering alloys. There are many benefits of selective soldering. The best is the better process. reliability, and more consistent reproducibility of soldering result. This is due to technical advantage, example of selective soldering that can be individually programmed and monitored for specific soldering points, selectively control the amount of flux and soldering time. Also can definitely achieve higher quality, significantly lower cost due to the selective soldering, which can be done with considerable acceleration. The manufacturing process of selecting and soldering the selected technology. When surface mount components are mounted on both sides of the printed circuit board assembly, the wave soldering of through-hole components is not always possible, nor is manual soldering good compromise. Many through-hole components cannot be replaced by surface mounts technology, especially when high mechanical loads are involved, such as connector or switches power electronic. It also needs through-hole mounting on the printed circuit board to help dissipate heat. The various variants of the printed circuit board assembly are usually composed of temperature-sensitive components. Used in combination with high heat capacity components on the same printed circuit board assembly. Manual intervention of wave soldering or manual soldering usually result in soldering too low or too high temperature, and therefore quality issues are inherent. This can be selectively eliminated by using soldering process. In most cases, selective soldering consists of three stages. Firstly, application of flux or liquid flux. Secondly, preheating or printed circuit board assembly. And third, soldering using site-specific soldering nozzles. Even the programming is fully developed and can be set up by the operator without prior knowledge. Program within minutes tend to Northern Select software. Due to its inherent flexibility in the process, selective soldering can be successfully used for large-scale soldering. A group of printed circuit board PCB assemblies and has many distinct advantages, including: first, process improvement can be obtained safely and quickly. Second, ensures reliability solder joints without overheating the components. Third, granted duplicating process. And lastly, eliminates the use of expensive aperture with solder pads or masks. Next, I will pass to my other team member. Next, I will proceed to the conclusion. In this experiment, we complete the task and know the soldering equipment. In addition, soldering equipment is the most essential tools for soldering process, which consists of soldering station, soldering iron, and sponge. Then, we learn soldering and desoldering techniques for connecting electronic components on PCB boards through the procedures in the lab sheet that was given by the lecturer. After that, we learn tips and technical guidelines for soldering and desoldering. From the lab sheet, we know that we need the 3D visualization that we designed from lab 2 to do question 4 to show the top view and bottom view to show the installation of the components in our circuit. Furthermore, we learn each step of the process through the guideline from the lab sheet. Last but not least, we know each step in the process is important in order to produce the perfect soldering on the PCB board. Lastly, we also know to test the assembled circuit for correct functionality. That's all from our group. Thank you.